So how long did you spend to put this together?
The original machine took me 3 months from conception to build.
Yeah.
And then I redid the animation with what you see here, and that itself took me another 3 months. But in total progress, I've been working on it 2 years after the point where you see it now. Took me quite a while to save up the money and learn the programming I needed to. And I taught myself 3D modeling, 3D animation, 3D printing. Yeah. So I could do it.
That is pretty slick. That's pretty impressive.
Thank you. Let me show you something kind of cool. If I get my light on my phone here.
Oh yeah. So do you sense when it's in exactly the right spot for flash, or is it hard coded by encoders or something?
It's sensed because I'm using not precise equipment.
Yeah.
So it does count the teeth. So I can show you the back here. Back here I got a sprocket and I got this teeth counter.
Yeah.
It counts the teeth, and when it's in the right position, it will tell this board over here to flick the light. I got an Arduino controlling it with a motor shield above it, which is controlling the motors. A custom-built light board that will send the right current to these lights because they're actually 900 lumens each.
Oh wow.
Which basically says if I put full current through them without them flickering, they'd light up this room.
Yeah.
Because they're flickering at such high speeds that you don't really notice the brightness. So I had to build a board that allows the power to go through it while not frying the Arduino board, which I went through 3 Arduinos.
To get that straight?
Yeah.
So you put them a millisecond or so?
They're on for, there's a 47 microsecond gap, and it's on for 300 microseconds. So you do 0.0003 seconds.
Where did you get the inspiration to make this?
In all honesty, I'm a amateur wannabe physicist, and I was thinking about particle interaction, and I really wanted to figure out how to way of showing it. And it actually led to a breakthrough I had in creating a different version of this machine, and it's extremely expensive to build that one. So to get there, I built this to prove that I could create similar principles, but strictly to prove the concept of three-dimensional animation in 3D space, so that I could hopefully find funding to go further that way, which is based on physics. So that's the real story of this.
Wow.
Yeah. But it's actually based on a lot of different things. A lot of old school film systems, zoetropes specifically. Zoetropes, they're out there, they're like basically you take a record player and you put 17 different objects on it that look very similar but look like slightly different. It would spin on top of the record player and the light would flicker. Well, I hated that design because it limits me to only 1 second of animation. This is 4 seconds long, and it's not at all difficult for a machine that's this longer, same size but out to here. I have a design that I can do 2.5 minutes. So, limitation of 1 second I hated. Secondly, I hated the fact that you saw them all at the same time. So I wanted to figure out a method of isolating the frame that you're seeing. So this design gives me that ability to isolate, while also giving me the ability to basically extend it however long I want it. The one problem with this thing is it's extremely time consuming to make. If I wanted to do, say, like a Pixar movie, it would be millions of dollars and hundreds, if not thousands of hours to produce. Well, like I said, this is just the proof of concept for this flickering in 3D space. The machine I started working on after this is actually one you can put your hand through. It's extremely, I can only do a 2D square floating in 3D space, which you put your hand through. Problem with it, when I patented this, I found out someone patented the thing I'm working on. So they beat me 2 months to it. The object you're looking at is something called a hypercube. I do not expect anyone to know what that is. It's extremely geeky. It's a theoretical four-dimensional object in mathematics. It does not exist. It's totally fake. So this is a representation of what it would look like in 3D space, in the same way that if you take a cube and push it through a piece of paper, or like a CAT scan, it gets all those slices. This, in theory, is what a four-dimensional object would look like coming through 3D space. Again, super geeky, no one knows what it is. But because it's here, I'm going to explain it. So what that means is you got a line, which is a 1D object. You got a square, which is 4 lines. Then you got a cube, which is 6 squares. And you got a hypercube, which is 8 cubes, basically. So I did that because there's no way to recreate this object in any other method out there in real space. I did it just to show it off, to show what this thing can do. Which, again, no one knows what it is. So, because I originally did Lego guys. It was just a Lego guy taking his hat off. It wasn't that impressive. Let me show you guys. Just to kind of show it out. And just to mess with y'all's heads. Yeah.
Yeah, there you go. Yeah.
And to show you how it works, it's based on the same principles of old school film. So you have a film strip, and each image on it is slightly different than the next, and it displays one after another in rapid succession. There's something called persistence of motion, which is where your brain will stitch together very similar images and see motion in it. At about 12 frames a second, your brain really starts putting it together. If it's less than that, you start seeing like things like this, like a strobe light. This is running at 24 frames a second, which is what movies in the theater are like. So, like that 2D film, instead of being 2D, it's 3D. It's three-dimensional objects. It shows one frame, the light flickers, burns that image in your eyes, and then the light goes out, the next one comes up, flickers again, and burns that in your eyes again. And then your brain just stitches it together and sees motion. And then this is what you got.
I got something I got to show you. Yeah.
Well
Let's
done.
show you.
Wow, that's
Show you.
amazing. That's really cool.
I want to use it for education purposes. To do things, to show things that you can't see otherwise, like this object itself. As you heard, they're new here. This is a tesseract or hypercube. This doesn't exist. It's not a real thing. It's theoretical. In physics and mathematics is the difference, but either way, it's not supposed to exist in 3D space. This is the only three-dimensional tessellating tesseract in the world. The reason being is nothing can actually create this motion where it interlines and draw out itself. And that's why I did it, because I just really wanted to show off what this can do. The problem is no one knows what that is, so it's not that impressive. So I have to explain it. But again, it's a great opportunity for me to teach people a little bit about something. I really want to do modeling of particle physics and interaction with molecules and stuff like that. But
So this is very impressive. This is
What's the
fantastic.
flash rate?
it's 24 frames a second. The flash is on for 300 microseconds, and there's a delay between the flashes of about 47 microseconds. So not milliseconds, microseconds, which is even faster than normal. It's 0.0003 of a second. The LEDs themselves are 900 looms each, and I got 2 of them. To put that in perspective, if I was not flickering them and had full current running through them, it would light up this room. Due to the speed that they're at, it's really hard to tell. And then the delays and aspect and so forth. So it works on the similar principles of just old school film. This is really reminiscent of zoetropes. There's, you might have seen like the Pixar ones. It's basically if you take a record player and you put 17 objects on it that are slightly different, and then you have a strobe light, you'll see them moving. I hated the design because it gives you only 1 second. This is 4, and I can actually easily design. I have designs for longer. And I've got a machine similar to the size of this in 2.5 minutes. So I hated that, and I also hated the fact that you see everything at once. It would be like watching a movie and seeing all the frames in different places. this isolates the frame through the design of it. I currently have 40 frames on here. I 3D printed every single frame. It took me about 50 hours to print and 50 hours to clean. So like 100 hours total to get all the frames ready.
So this year ago, iconic show, and I'm actually going there again. I'm meeting a guy named Tony mine, and I'm meeting him. I do photopolymer for holography.
You know what it's saying from this angle of the viewing angle here?
There's a little parallax.
So you can see, it's the same image from any angle, or you get to see
No, you get the other side. You get the full image. So if you're looking at it this way,
I've been working on a design like this, actually.
okay. And this guy is he's got some interesting things going on, and very friendly guy, especially for the
Yes, it is. Animated GIF.
Yeah, kind of. I know it's,
Yeah.
do you have any questions? You want to see it in full light?
My question, why is one of the frames just randomly red?
Because I think it's interesting, but the real reason is because I was displaying this somewhere, and on the way there I got in a car wreck and it broke one of my frames, and it was the only spare frame of this frame that I had. So I just threw it on there, and no one noticed. Until you just look at it, or if it's in pitch black, you just look up here, you don't notice it, but you can see it down here.
Yeah, you see it coming up, then it's gone really fast.
And the second thing is, not only is it red, it's warped and bent, which is even more intriguing to me. And it really demonstrates the concept of persistence of vision and how much our brain will stitch things together.
Fill in the blanks between what makes sense.
Yep. I know the noise is kind of annoying and loud, but that's partly due to the open case design and also not superposition manufacturing.
It's not precision belts.
Yeah. Precision manufacturing, cut down, better materials, better motors, and then also soundproofing the case will go a long way of decreasing the audio to a point where it'll sound probably like an old school real projector. Just you hear the flicker, but nothing too annoying, obnoxious. And then long term, we can put sound speakers on something and mask the noise.